Alright, in this video I want to do a couple of examples of just solving some basic rational equations. And there's a couple different ways that you can solve rational equations. Everything gets you to the same solution. One way you can do it is you can multiply both sides by the least common multiple of the denominators. And what that will do is it'll get rid of all the fractions involved. Or you can just try to write both sides of the equation as a single fraction and then cross multiply. As a rule with rational equations, you want to check your solutions just because sometimes some weird things can happen. Namely, one of your solutions may produce a value that's undefined. So in general, you do want to check these. I think the way that I'm going to do these, at least when they're relatively simple, I like to write both sides as a single fraction and cross multiply. So, okay, a couple examples here. So in the first one we have negative 2 over x plus 5 over x equals 6. Well, in this case, this one certainly isn't too bad. Notice we already have a common denominator. So that means we can simply write it as a single fraction. Negative 2 plus 5 over x equals 6. And you can simplify the numerator here. Negative 2 plus 5 would simply be 3 over x equals 6. And certainly here you could just multiply both sides by x, but again, just to illustrate this idea of cross multiplication, you could think about 6 as being 6 over 1. And again, when we cross multiply, we take the stuff in the denominator of one fraction, multiply it by the numerator of the other fraction, and vice versa. Okay, so on one side, it doesn't matter which side of the equal sign you put the stuff, as long as one part goes on one side and one part goes on the other. So I could write 3 times 1 on the left side, and then I have x times 6, which I'm just going to write as 6x on the right side. And well, now we just have 3 equals 6x, and if we want to solve for x, we simply divide both sides by 6, and 3 divided by 6 would be the number 1/2, and you can check that if you plug 1/2 back into this original problem, we will get the value. When you plug it into the left side, we will get 6 out as our solution. Okay, so one other one here, we have negative 3 over x plus 5 over 2x equals negative 6. So in this case, well, we don't have common denominators yet, but in the denominator of our second fraction, we have a 2x. We only have an x in the bottom of our first fraction, so we could simply multiply the numerator and the denominator of the first fraction just by 2. So in the numerator, we'll have negative 3 times 2, which would give us negative 6, again over 2x, plus 5 over 2x. And on the right side, we have negative 6. And again, now that I've got common denominators, I can do the arithmetic in the numerator. So negative 6 plus 5 would be negative 1 over 2x. If I write the right side as a single fraction, or as a fraction, I can just write that as negative 6 over 1. And again, just like before, if I cross multiply, I can take negative 1 times positive 1, which would be negative 1. If I take 2x times negative 6, well, I think a negative and a positive is a negative. 6 times 2 is 12, and then we have the x left over. And to get the x by itself, all we have to do is simply divide both sides by negative 12. On the right side, we'll be left with positive 1x. A negative over a negative is a positive. We have 1 over 12, which doesn't really reduce, and we will get our solution of x equals 1/12. So again, I certainly encourage you to plug it back into the original, do the arithmetic on the left side, and you'll see at the end of it you do get the value negative 6 out as your solution.